Hello students, Strite here again. Today we're going to start in on notes for chapter 10 titled The Mole. In chapter 10, 5 sections titled Measuring Matter, and one we're going to be looking at today, and later we'll look at mass in a mole, section 2, section 3, moles of compounds, section 4, empirical molecular formulas, section 5, formula hydrates. Should have already done some Hummer notes on section 10.1. Make sure here you add anything additional you need, plus read the section, add any other things you need, and jot down any questions you have as you read so you can bring them up in class. In section 10.1, our objectives explain how a mole is used to indirectly count the number of particles of matter, relate a mole to a common everyday counting unit, and convert between moles and represented numbers of particles. Review vocab, molecule, 2 or more atoms that covalently bond together to form a unit. A couple new terms will come up with: mole and Avogadro's number. Our main idea: chemists use the mole to count atoms, molecules, ions, and formula units. Now, chemists need a convenient method for accurately counting the number of atoms, molecules, and formula units of a substance. You need some type of unit because an atom is so very, very small, and to count them we would have a tremendous number of them. A mole is our SI unit to measure the amount of the substance. And a mole is the amount of atoms in 12 grams of pure carbon-12, or it turns out to be 6.02 times 10 to the 23rd representative particles. Usually in this course we'll be using 6.022 times 10 to the 23rd. You want to remember that number? It's the number of particles in a mole. That can be any kind of a particle. It doesn't matter if it's an atom, a molecule, a formula unit, an electron, an ion, doesn't matter. That's a mole. And we call this Avogadro's number. So, Avogadro's number of particles in a mole. We'll be doing some conversions in class time. We'll do quite a number of these. Here's a brief example. So if we want to go from moles to particles, our conversion factor is going to be this. Again, we're going to do 6.022 when we get to it. So our question: number of molecules, 3.5 moles of sucrose. So we're trying to go from 3.50 moles of sucrose to molecules. So using my method that I usually show you, we would put the 3.50 moles in here, and then 1 mole is 6.022 times 10 to the 23rd molecules. And our little calculations, we get two proper number of sig figs, 2.11 times 10 to the 24th molecules. Yeah, we could go from particles to moles. So we want to, if we have 2.11 times 10 to the 24th molecules, we would know that there's 6.022 times 10 to the 23rd molecules. and 1 mole. Molecules cancel molecules. This time we do a little division, and we come back to that 3.50 moles of sucrose. Again, we'll do a number of these in class. We'll be very good at them. So, what does a mole measure? You should know that's the amount of the substance. And the conversion factor for determining the number of moles of a substance from a given number of particles. So we want to go from particles to moles. That means we'd be starting with particles. So our conversion factor, we need that on the bottom, and we need mole on the top, which is what they're illustrating here. So that's a little brief look at section 10.1. That's all for now. Till next time, Stride.